Dear students, the given question is, if R and H are the horizontal range and maximum height attained by a projectile, then what is the speed of projection in terms of R and H? So here you are asked to find out initial velocity of projection, speed of projection. You are asked to find out the speed of projection. First of all, if you try to see the projectile, when any body is projected into the space at an angle theta other than 90 is named as a projectile. Now it is being projected with an velocity vector u bar at an angle, making it an angle theta with the horizontal. Now if you make the velocity into two parts, one is u cos theta, other one is u sin theta. So u cos theta is named as ux, horizontal component of velocity. U sin theta is named as uy, initial vertical component of velocity. So as soon as the projectile is projected, so as it is an oblique projection, it will have two directions of motion, which are horizontal as well as vertical direction of motion. Now the projectile path would be like this. Projectile path would be, this is the path which is named as parabolic path. So at the maximum height, it will have only horizontal component of velocity, which is named as u cos theta. Whereas vertical component of velocity, final vertical component of velocity becomes 0, then that height attained by the projectile can be called as h max, which is given as h. And the maximum horizontal distance traversed by the projectile during a time of flight can be called as range. So here to here it would be the range. Now we are asked to find out speed of projection in terms of R and H. We are asked to find out speed of projection in terms of R and H. Okay. So let me consider the initial formula for the basic formula for maximum height. The basic formula for maximum height, as we already know that h max is equal to uy square by 2g. So from this, uy square is equal to 2gh. Already h max is nothing but h is given. So therefore u sin theta is equal to, because initial vertical component of velocity is u sin theta, which is nothing but square root of 2gh. So this is the equation 1. And then as the projectile is projected, so time taken by the projectile to move from ground to maximum height is time of ascent, and then maximum height to the ground. If you try to consider this part, this would be time of descent. Okay. So as the projectile is projected from the maximum height, as the projectile is moving from the maximum height to the ground in downward direction, if you try to see that here in the downward journey, initial vertical component of velocity is 0. Means in the downward journey, means I am making the situation into two parts. One is upward journey, second one is a downward journey. First half is upward journey, second half is downward journey. In the downward journey, what has happened? So initial vertical component of velocity 0. So now I am applying a second equation of motion. As I am trying to apply second equation of motion, Sy is equal to uy into t plus half ay into t square. Sy is as the displacement of the particle is a downward. So vertical displacement is downward, minus h is to be taken, and time of descent is half of time of flight. So our intention is to calculate time of flight in terms of h, so that our situation can be solved very easily. So therefore minus h is equal to 0 into t by 2 plus half into minus g into t by 2 whole square. So this is anyway 0. So here this minus gets cancelled. So upon simplification, we will be getting it as h is equal to half g into t square by 4. So therefore t is equal to, or t square is equal to, if you see that, so 8h by g, and t would be, so time of flight would be in terms of maximum height is a square root of 8h by g. This is time of flight. Now range r is equal to, range r is equal to horizontal component of velocity into time of flight. This is basic formula. Basic formula. So therefore r is equal to, range r is equal to horizontal component of velocity u cos theta, which we don't know, which we, from this only we are trying to use and get the value of u, into time of flight is 8h by g under root. So upon rearranging, so what do we get over here? So r into root g by 8h is equal to u cos theta. This is equation 2. This is equation 2. Next, squaring and adding equation 1 and 2. Equation 1 square plus equation 2 square will give us u sin theta whole square plus u cos theta whole square is equal to, already u sin theta is none other than square root of 2gh whole square plus u cos theta, just now we have calculated that, r into square root of g by 8h. Now this is also whole square. So therefore here the remainder is u square, which is equal to 2gh plus r square g by 8h. We want initial velocity of projection, u is equal to square root of 2gh plus gr square by 8h. This is the result which we require. Okay, thank you.